For decades, scientists have been probing the Greenland ice sheet from the ground, air, and space. Now a new study uses those observations to see within the ice sheet, laying bare a tale more than 100,000 years in the making. When we look inside an ice sheet, we can see distinct layers formed by thousands of years of snowfall. As snow accumulates, these layers get progressively compacted into ice, which then flows under its own weight. To get a precise history of a particular spot on an ice sheet, scientists drill into it and recover ice cores, which provide a record of the ice's age and what the past climate was like. Seasonal variations, along with ash from volcanic eruptions, show up in the cores, allowing us to date the ice and correlate samples from different sites. To extend this age information across the ice sheet, the best tool that we have is ice-penetrating radar, mounted on aircraft flying low over the surface. Radar transmits electromagnetic pulses into the ice and records the reflected signals, allowing us to track the depth of the layers detected in the ice. Since 2009, NASA's Operation Icebridge has flown over Greenland more than 100 times with a wide variety of instruments, including radar, and produced vast quantities of data, adding to the work from many other missions. This has allowed researchers to generate a three-dimensional map depicting the age of the ice throughout the Greenland ice sheet. This 3D age map shows that three distinct periods of climate are evident within the ice sheet. The Holocene, shown here in green, the last ice age, shown in blue, and the Eemian, shown here in red. The top layers from the Holocene period formed during the last 11.7 thousand years and are fairly flat and uniform, though the thickness varies depending on how much snowfall occurred. Below this, deeper within the ice sheet, we see layers that formed during the last ice age. Layers from this period are darker and more complex, having been further squeezed and sometimes folded as they flowed over the rugged bedrock below. Deeper still are layers of ice left over from the warm period before the last ice age, more than 115,000 years ago. Eemian ice can reveal how the ice sheet responded to a period of warmth similar to the one we are experiencing today. Several ice cores have recovered Eemian ice, but it is difficult to interpret. This new map of the age of the ice sheet shows that there is more Eemian ice than expected in northern Greenland, where it may be easier for scientists to collect and analyze. This new analysis reveals a 3D map of the age of the Greenland ice sheet, from the oldest Eemian ice to the layers deposited during the last ice age to the ice that formed during the Holocene. The response of the ice sheet to past climate change led to its current age structure. Further study will help us better understand how the Greenland ice sheet will respond to today's changing climate.